I'm going to write the instructions again. So absolute value greater than, get absolute values alone, and then remove them. Okay, so there's the instructions for those two different parts. So do you see right away how we can eliminate some of the answers? Like on number 1, it's absolute value greater. So you know the answer has to end up with infinities. Two different intervals with infinity, so it can't be C and it can't be D, huh? Do you see that right away? How if you just have on your 3x5 card, and remember the best way to make your 3x5 card is as you're doing the practice exam. So even right now, if you want to write things on a side paper that you're eventually going to put on your 3x5 card, you for sure want to have that, absolute value greater or less. So, okay, so what do? We just take, we go 6x. Well, here, I think I better go to a fresh screen where there's a little more room. Let me do that. So, there we go. So, number 1. So absolute value of 6x minus 3 less than or greater than or equal to 5. Okay, and so what do? We break it into 2. Less than, you got to really pay close attention to the direction of the symbols. It really matters. Less than or equal to -5 or greater than or equal to +5. And then we just solve them both. So add 3 to both, and add 3 to both here. And so we get 6x less than or equal to -2. Over here we get 6x greater than or equal to 8, and then divide by 6. And then see if you can reduce them. These cancel. And so this would be x less than or equal to 2, and then divide top and bottom by 2. Right? We always reduce fractions whenever we can, right? -1/3 over here, x greater than or equal to, reduce the fraction 4/3. So that's going to, remember the form of the answer, it says it's going to be -infinity, -1/3, united with 4/3 to infinity. So there it is. Let's go back and see it. Which number is that? Was it I already forgot. Let's go back again. It is A, isn't it? So it's answer A on the multiple choice. Number 2 is absolute value 2x plus 2 less than 3. So what does it say for that? You put the negative number, the less than symbol, another less than symbol, and then the positive number. So pay close attention to the format. That's the format that I'm describing to you. And then we got to get x alone, right? So, right, you see the format, how they're both less thans for the absolute value less than? When you remove the absolute value signs. See how I removed the absolute value signs? and I wrote the inside with both less than symbols, the negative on the left, the positive on the right. Now x is right here in the middle saying, I want to be alone. Get rid of these two 2's. So start by subtracting 2 all the way through. And we'll get, what's that, minus 5, 2x1. Last step, divide through by 2. So there it is. X is between a half and minus 5 halves. So that's minus 5 halves and a half. And so minus 5 halves and a half, that answer's not there, is it? It's E, none of the above. It's just not there. We go back, minus 5 halves to a half, right? So number 3. So I hope you have a really clear x squared game plan, right? So what is the x squared game plan? Well, there's two kinds. If you have x squared and x with an equal sign, then step 1 is get a 0. Step 2, you can try to factor if you want, you know, with the 2 parentheses, or you can do negative b plus or minus the square root of b squared minus 4ac all over 2a. You can do that. Now, below that, I want to make sure I also add, how do you handle x squared and no x to the first? So up here we have x squared and x to the first. And then secondly, what about, see like this problem right here, how we just have an x that's squared? That x in the parentheses is really a squared x, isn't it? Because it's under the influence of a square. So we know it's really squared. So, okay, what do you do differently in that case? You get the squared piece alone. You don't get a 0. You get the squared piece alone, and you do the root and the plus or minus root. So again, this would be really good to have on your 3x5 card. So the absolute value greater than, less than plan, and the x squared with x to the first, and the x squared without x to the first. Have those two game plans so that when you see them on the exam, you know right what to do. And so we say, okay, so let's do it. So up here, I've got 5x squared plus 12x minus 3, or whoops, equals minus 3, huh? Equals minus 3. And so I need to get x, first step is get a 0. So add 3, boom. That'll give me 0. 5x squared plus 12x plus 3. Good so far. So step 1, get a 0. Step 2, you can try to factor. I don't think that'll even factor. So I'm just going to go right to the quadratic formula. Negative b plus or minus square root b squared minus 4ac all over 2a. I'm going to identify a, b, and c. So a is the 5, b is the 12, and c is the plus 3, huh? So here we go. So it's going to be negative b, negative 12, plus or minus the square root of b squared, 12 squared, minus 4 times a, which is 5, times c, which is 3, all over 2 times a, 2 times 5. And then work that out. That'll be minus 12 plus or minus the square root of, what's that? Use your calculator. 144 minus, I don't know, 2060, all over 10. And so then that is minus 12 plus or minus square root of 84, right? All over 10. I think. Did I do that right? Yeah. So we get to there. Good so far. So now I've got to simplify the square root of 84. Remember how to do the square root of 84? I'll bring it over here. What do we do to simplify the square root of 84? break it down with our calculator. Remember that? So this will be like 2 times 42. This is 6 times 7. 2 times 3. So 2, 2, 3, 7. Let me make that a little neater there. 2, 2, 3, 7. So the square root of 84 is 2 times 2 times 3 times 7. And remember what square roots do? 2 for 1 deal. They're 2 for 1 deal at target. 2 2's in, 1 2 out, and they're gone. So it becomes 2 root, and then the 3 and the 7 go back to 21, don't they? So it's going to be 2 root of 21. 2 root 21. So, okay, so let's go back to this problem. So this becomes minus 12 plus or minus 2 root, I'm running out of room here, huh? Squeeze this in. So this is minus 12 plus or minus 2 root 21 all over 10. Everybody seeing that? Minus 12 plus or minus, or maybe I should bring it down. That'd be better. Let's bring it down. So minus 12 plus or minus 2 root 21 all over 10. And then, here's the real tricky part. Wouldn't it be a bummer to get all this far and then not know the last step, right? So remember the last step? What can we do? Can I go like 2 into 10? Can I go just 2 into 10?
No.
No. What do I have to do?
You have to go...
All 3 of them, huh? All 3 of the outsiders. Remember that? Because they're glued. Remember the Costco thing? On the top, that plus and minus. What they're saying is, look, I'll circle them. All 3 of those, because if all 3 of them can be divided by the same number, you do it. If any one of them can't, forget it. Just stop, and you're done. Does that make sense? 2 does go into all those numbers, doesn't it? So I'm gonna do it. I'm gonna divide them all by 2. Is that making sense? Now, again, if any one of them couldn't, like here's what'll happen sometimes, guys. There'll be like no number in front of the root. And here's a common mistake. Sometimes students will say, well, there's nothing there, so I can just do the 12 and the 10. Nope. Guess what number's really there? There's really a 1 there. If there's nothing there, there's really 1, and 1 is not divisible by 2. So I would just stop right here, wouldn't I? Does that make sense? But in this case, we do have a number. We have a 2. So yeah, they're all, so divide by 2, divide by 2, divide by 2. Divide them all by 2, leaves minus 6, leaves 5, and leaves 1. So we get, what do we get? Minus 6 plus or minus 1 root 21 all over 5. And you don't need the 1. 1 times root 21 is just root 21. So is one of those answers right?
D.
Yeah, there it is. D, huh? Remember that last step? So if all 3 of the outside of the root numbers, if all 3 of them are divisible by the same thing, you do. Here at the end, so let's go to number 4 now. So number 4 was x plus 9 squared minus 2 equals 3. Okay, so remember what I said when you have x squared and no x to the first. These are easier. You don't have to get a 0. Step 1, you get the x squared alone. Or the big old parentheses squared piece alone. Get this big thing alone. So don't get a 0. It's a whole different game plan. That's why you have to have these recipes, so to speak, on your 3x5 card. So when you see this question, you go, oh, this is one of those. All I have is an x that's squared. I don't have any x to the first power, right? You may think, well, yeah, that's an x over. No, he's under a square. He's really x squared. So get him alone. So what do we do to get him alone? We just add the 2, right? Cancels out there. And I get x plus 9 squared is 5. So step 1 is you get alone. Step 2, what do we do next? Yeah, the root and the plus minus. Remember I said when you put a roof on the house, my dorkiest saying, right? If you put a roof on the house, you got to go up and down the ladder. It's just dorky enough, you'll hopefully remember. So when you put so the way to get rid of a 2 power is a root. They're opposites of each other. So when you got a 2 power in there, You root this side and root that side. I put a roof over both sides, a root over both sides. When you put a roof on your house, you got to go plus or minus up and down the ladder like that. Got to have two answers. So the root cancels the square, right? They're opposites. So we get x plus 9 is plus or minus root 5. Last step to get x alone. Now that we got rid of the 2 power, it's not hard. How do we finish getting x alone? Just subtract 9. Boom. And so that's going to be x minus 9 plus or minus root 5. You just pop that minus 9 in the front there. Minus 9 plus or minus root 5. Or you could, did it confuse you that I didn't break it into 2? If that bugs you, you can break it into 2. Here, I'll go back and do that. Maybe that'd be better. So x plus 9 is plus root 5, or x plus 9 is minus root 5. That's fine also. Either way. And then subtract 9 from both sides. Subtract 9 from both sides. And get the same two answers. Minus 9 plus root 5. Minus 9 minus root 5. And so that's option A, isn't it? So shall we try number 5 here? This is a greater than, less than kind of question. So we have 2x plus 7 plus 11 greater than or equal to 5x plus 4 plus 14. So it's just a bunch of multiplying through the parentheses and gathering like terms and all that. And so let's do that. So I'm going to distribute this in. So 2x plus 14 plus 11. And then the 5 distributes in. 5x plus 20 plus 14. So that's 2x plus 25. It's 5x plus 34. Okay, so at this point, what do we do when we have x's on opposite sides like that? I'll just go to, I usually go to the lower one. It doesn't really matter which one. I'll subtract 2x from both sides. Gets rid of that one. And then we have 3x plus 34, 25 over here. X is saying I want to be alone, so we have to subtract the 34 from both sides. Is that like minus 9? Yeah, that's right. And then, last step, divide by 3, right? Do I need to flip the symbol? No, I'm dividing by a positive. I'm putting a positive number under there, so I do not need to flip the symbol. So that's -3. Now, that's a fine answer, but it's kind of weird, and it's hard to tell which is right. I like to flip them, like the whole thing around. I like the x's on the left. So it's just easier to read. So if you flip the entire thing around, not because of dividing by a negative or anything, just make it easier to read, put the x on the left. Flip the whole thing around, including the symbol in the middle. That's saying the same thing, isn't it? That's the exact same answer. See how x is on the narrow side of the symbol in both cases? See, x is on the narrow side here. X is on the narrow side here. X is less than or equal to -3 in both cases, huh? So which A, B, C, or D is the right answer? Less than or equal to -3? Yeah, can you all see it's B? Right, that's what that means, right? -3 down to -infinity. Is that good? And, honestly, about the brackets and the parentheses, I'm not going to mess with you on that. You have plenty to worry about. Like, you don't need to sweat it. I'm not going to put the exact right answer in there and just make it a parenthesis instead. Go, -3, it's a parenthesis. Oh, you didn't notice. It's wrong. It's none of the above. That's just dumb. So don't worry about it. That's not going to happen. Right? It'll only be none of the above if it's just really not one of those answers. I'm not going to try to trick you with the little parenthesis bracket thing. All right. Good to number 6. All right, so to number 6, it says, I use the graph of f above to find f of 20. I'll give you a second there. There's really nothing to calculate. It's just reading it off the graph if you know how to read that. What do you do with f of 20 here? What is that? The question is that 20 an x or is it a y? X, because remember it's always f of x that yes, that's an x, huh? So basically that means go to 20 on the x. See the x here? This is the, I know it's pretty tiny. Yeah, I'll make it bigger. That's the x-axis, right? So do you see how that's 50 out there? So this must be like 10, 20, 30, 40, 50. See that? See how they go by tens? So if you go over to x20, if you go to x20, which is right here, and go down to the graph, there's the dot right there. This is over 20, isn't it? That dot right there? Negative 40. Yeah, can you all see that? This is down 40, right? This is down 30, down 20. Wait, I'm getting confused. No, that's right. This is negative 50 here, negative 40 here, negative 30 here, negative 20, negative 10. Yeah, right. So if it's over 20, down 40. So that must equal then negative 40. F of they're asking, this is the x, this is the y. They're asking the y value on the graph that goes with the x value of 20. It's none of the above. It should be negative 40, and it ain't there. So it's none of the above. So there will be some none of the aboves on the test. Not a lot, 3 or 4, probably. Is that good? Does that make sense how we found that? So the whole key to reading that is x plugs into the parentheses. What it equals is y from the dot on the graph. All right, I'll move on. How about this other graph one? How about number 7? All right, so where they're saying f of x equals, so again, this is x, obviously it says it's x, and this is y. Yeah, so this is the function f. Where do you see this function has a y height of 0? Here, here, and here. 3 places, huh? That function f is at a height, a y value of 0 at 3 different places. What is that? Negative 30? And then I can't tell what this one is. It's 30, 35, I guess, and 50. Yeah, A. Does that make sense? Those are the 3 x values that have a y height of 0. All right, number 8. They want us to put negative 1 into that function. So that's just a plug-in deal. Right, f of negative 1. That just means you plug in the negative 1 everywhere you've got the x. Is that good? I put parentheses around it. It's a good habit. It'll keep you from errors. Mostly. So when you plug into a function, put parentheses around the number and plug it in right where the x's were, right? Because the x's are like the holes in the toaster. They're the insert slots, aren't they? So it's going to go right there and right there. Those are the holes in the toaster there. So we plug that in, and then we work it out. So what does that become? What is negative 1 squared? Positive 1 minus 8. And then this is negative 1 plus 2. What is that? Negative 7 over positive 1. Negative 7. There it is. Is that good? Do it in pieces. So in other words, first they want f of x plus h. So just find f of x plus h. That means you take this whole function and you plug in x plus h there and there. So we'll get x plus h squared plus 6 times x plus h plus 4. So that's just the first piece of the puzzle. Does everybody see that? I'm going to do it one part at a time because this can be really messy. So I'm grabbing this piece right here and I'm plugging in x plus h. All right. So what do we get? Well, remember what the 2 on the parentheses means? you got to write 2 of the parentheses. Like that. Remember that whole thing? And then you just got to go multiply first to both, second to both. So I'll go first to both. X squared plus xh, second to both, plus xh plus h squared. And now the 6 will go 6x plus 6h, and then the 4. There we go. I just multiplied. So there's all that part, and then that part, and then that part. Now that, again, I haven't done the whole thing yet. That's just the f of x plus h. That's the messiest part, but let's keep bringing it down. This is f of x plus h. And let's gather some like terms. Right here in the middle, these guys are like terms, aren't they? So they'll become 2xh Everybody good to there? Now, we're going to take that whole thing, x squared plus 2xh plus h squared plus 6x plus 6h plus 4, and we're going to, what does it say? Subtract all of f of x, All of f of x. What's f of x? Well, that's the original function here, which is x squared plus 6x plus 4, and then put the whole thing over h, like that. So see how I've got it all together now? Right? Does everybody see what I did there? I basically grabbed this stuff and put it right there. Right? Because that's f of x plus h. You see that? Now we just need to distribute this. I'm going to bring down x squared plus 2xh plus h squared plus 6x plus 6h plus 4. And then that minus, boom, boom, boom. Minus x squared minus 6x minus 4 all over h. And now we cancel whatever we can cancel. This is the one where everything will cancel that doesn't have an h. I don't know if you remember this one. So all the non-h terms will indeed cancel here. So x squared and minus x squared. See how they cancel? Because he doesn't have an h. 6x and minus 6x. See how they cancel? Because he doesn't have an h. And 4 and minus 4. See how he cancels? Because he doesn't have an h. See how the things without h's canceled out? That'll always happen. There will for sure be one exactly like this. I mean, different. Might give you x squared plus 2x minus 7, but basically the same thing on the exam, because this is an important thing for calculus if you're headed that way. So what are we left with? 2xh plus h squared plus 6h. Well, that's it, all over h. Just the 3 terms that had h's in them, And what do you do on the last step? How do you? All 3 of those are divided by the h, aren't they?
Get rid of 1h from each.
Get rid of 1h from each. Exactly. Couldn't have said it better myself. So it'll cancel one of these, leaving x to the h to the first there in the middle, and get rid of the x at the back, h at the back. There it is. 2x plus h plus 6. It's answer A. So I'll write it here as well. So for any domain question, number 1, if you have a root, you have the inside of a root, you take it out and you say inside, you got to be greater than or equal to 0, and then you solve that. Or step 2, if you have whatever blah, blah, blah over some denominator, you take the denominator, say denominator, you cannot equal 0, and then you solve that. What do we have? We have the root, so I'm going to grab the root, and I'm going to take the inside. I'm going to take the inside of the root. I'm going to pull the snail out of the shell, right? Just take the inside out of the root and say, hey, inside, you have to be greater than or equal to 0. Why? What is greater than or equal to 0? That means positive, doesn't it? the inside of a square root can't be negative. Remember, that's imaginary. We can never have a negative in a root because that's imaginary. So we got to solve that for x. So that one's easy. Just add 3 to both sides. We never want a negative in a root. Last step to get x alone, divide by 2. X is greater than or equal to 3/2. There it is. Answer B. So you might have a denominator on the actual exam, you know, like I gave you the rule for the inside of a square root or a denominator. Either one could be on the actual exam. Questions on number 11. Yeah, this is an important one. Which of those, remember the piecewise graphs? So these are challenging. Which of those 4 graphs is the correct piecewise graph? Can you read those piecewise graphs? You know what they're saying? Let me help. So what is this saying up here? This is saying, remember, f values are y values, right? Function values are y values. Y equals, f equals. Let's start with a 2 because that's easy. Let's just do this guy down here. Y is just at a height. Remember, y values are heights, right? Y is just at a height of 2 for all x values greater than or equal to 1. Y is at a height of 2 for all x values greater than or equal to 1. There's only one of the 4 graphs that holds that characteristic. Do you understand what that's saying? Can you see which graph that is? Yeah, exactly. It's D. See how this is at a height of 2? 1, 2. This right here is at a height of 2 for all the x values 1 or greater. Does everybody see that? D fits that perfectly. Y is supposed to be a height. I'm not even looking at that first part, x minus 5. I'm skipping it, going right to the easy part. Y has to be a height of 2 for x values greater than or equal to 1. That's right there. Y is at a height of 2 for x values 1 or bigger, isn't it? Does that make sense what that statement is saying? Now, why couldn't it be C? C's pretty close. What's wrong with C?
It's the sun. It has to be solid dot to be.
Yeah, it's got an open dot there, doesn't it? Remember, an open dot is wrong because it said greater than or equal. X is greater or equal. That means it should be, it's solid. It's right on the 1, like this one is. And so that's our answer. That's not too bad, right? Okay, good. So we didn't have to mess with the other part, the x minus 5 part, whatever, you know? It's the only one that could be the right answer. The rest must be right. There's not a none of the above there, notice. So that's what I'll do on the real exam. So that's not too bad. Questions on that one? That's the other part of the graph. So that's this part of the graph, because this is the part that goes for x values less than 1. So it's basically doing the function x. How would you graph the function x minus 5? That's what this is saying. Y is x minus 5 for x values less than 1. So how do you graph the function x minus 5? Do you guys remember that? Remember, you start at this number, negative 5, 1, 2, 3, 4, 5, right down there, negative 5. And then, so that's the first dot at negative 5. You got to find the two. It's going to be a straight line. We got to find the 2 dots. Negative 5 is the first dot. Remember how to graph with slope and the number off to the right? So you start with that number off to the right, negative 5. That's always on the middle line, the y-axis. So it's at negative 5. And then how do you find your second dot? That's the first dot. How do we find the second dot? Remember slope? What's the slope? Yeah, right here in the front. There's nothing in the front, which really means 1, right? Remember, when there's nothing in front of x, that's the same as 1 times x. And that's 1 over 1. That's the slope. Slope is in front of x. So this is rise and run. That means from this negative 5 dot, you go up 1 and over 1, and you got another dot. Connect those, and you got the line. See how we got that?
Yeah.
Up 1 over 1. It's because the slope is plus 1 over plus 1. 1 over 1, just 1. There's nothing in front of x, but that's the same as 1 times x. Positive 1 times x. So yeah. And now, okay, but why aren't they showing the whole line? Well, we're only supposed to show the parts that are what? Oh, that's the wrong one. The top one up here. What does it say? What does this one say? X less than 1. So you're supposed to not show this part. You're only supposed to show the parts that are at 1 or to the left. So open dot there. This exactly. Open dot there and going left because X value is less than 1 to the left of 1. So it is right. Isn't it? Does that make sense? It's all good? All right. Number 12. What is f of 4? Try that one. It should be an E, none of these. It's just not on the screen. And why am I saying that? Because it is none of these. It's not any of those answers. How do you know? Okay, well, what are you supposed to do? Well, this is the x value, right? Whatever's in the parentheses, right? F of x, that's always x. So I'm supposed to plug in x equals 4. But which of those do I plug it into? The top one, the middle one, the bottom one? How do you know? It's greater than 3. So you got to plug into that one. That makes sense? The directions on the right are telling you, right, this is for greater than 3. If you have an x equal to 3, or if you have an x, between -7 and 3, you plug into the top one. Do you see what I mean? So we're going to plug the 4 into that one because our 4 is a number greater than 3. So they're saying if you have a number greater than 3, plug into the bottom one. That's what it's saying. So I plug in there. So when I plug in there, I get -4 plus 6, which is 2. So the answer is 2, and it's not here. So it's none of these. Does that make sense? Good there. So it'd be good just to have these on your 3x5 card, these basic graphs. So does anybody just know which one's the square root of x? Yeah, it's this one. Yeah, so it'd be good if you have on your 3x5 card. Let me give you a few right now. Here'd be something else good to have. The basic graph of square root of x. The basic graph of, which one's this? Do you remember? X squared. And then the basic graph, the snake. Remember the snake? What's that one? X to the 3rd power. So it'd be good if you just had those basic ones right on your 3x5 card, because I'll probably test you on those like that. Here's another one. I can't remember if we've been over this, or maybe we'll go over it later. I honestly can't remember. This is 1 over x. It has 2 branches. It's kind of a weird one. Absolute value of x. I don't know if anybody knows what that one looks like. That's a V. That's a V shape. And, yeah. So, here we go. And let's throw in one more. Kind of a sideways snake. That's the 3rd root of x. There we go. There's the big 6. Put those on your 3x5 card. Available for you. And let's come on back. So we did answer that one. It's C there. All right, let's try this and find the average rate of change of the function between the values. So we have f of x equals minus 3x squared minus x from 5 to 6. Now, what's average rate of change? It's slope. It's y2 minus y1 over x2 minus x. So that was a hard section. Remember that section? Average rate of change is slope. We talked about it, I think, earlier. So I said a rate is like a speed is a slope, like miles per hour, problems per hour. So it's a fraction. So you want to put on your 3x5 card that formula. Okay. And now what are the 2 x values? This is x1. And let me do it here. This is x1. Well, I better do it here. This is x1. This is x2. So those will go on the bottom. x2 first, then x1. Good so far. And then what do we do on the top? F of those, meaning f of 6 minus f of 5. Because that's what y values mean. Remember, y values are function values, aren't they? Y values, see, we're seeing that theme a lot. Y values are function values. So it's f of 6 minus f of 5. Okay. Well, how do you find f of 6 minus f of 5? Well, remember, anything plugged into f goes in there and there, doesn't it? Remember, the x in a function is the holes in the toaster. You plug it in. Don't you? So we're going to plug it in there. So here we go. So f of 6, that means plugging in 6 here and 6 here. So we get minus 3 times 6 squared minus 6. That's f of 6. Subtract. And now plug in 5 here and 5 here. Get. Oh, boy, I'm going to run out of room, aren't I? All right. Come on down here. So, all right, so again, plug in 6 first off. Minus 3 times 6 squared minus 6. So that's f of 6 minus, and then f of 5 is going to be right here, which is minus 3 times 5 squared minus 5 all over 6 minus 5. Does everybody see what we did there? So that's when they say average rate of change. You do y2 minus y1 over x2 minus x1 slope, which is the f values over the x values. And then you just work everything out. Just use your calculator right here. This will become, I don't know, some number. Minus 114. And then minus, and then the other one is, what's that, 3 times minus 35, minus 80 over 1, huh? Bottom is just 1. And so what does that become? Well, it's minus 114. The double negative is positive. Remember that? So it's at 20, 30. Negative 34 divided by 1, but that doesn't do anything. There it is. Answer D, negative 34. So that's an important one to practice. 15. Here we've got a graph, kind of a little snaky graph there, or it's a curvy graph. So they're saying use the graph to find the intervals in which it is increasing, decreasing, or constant. So, and then they have multiple choice answers down there. So where is the graph if you're riding the roller coaster, right? You're here on the roller coaster, and we're always going to the right, huh? It's always as we go to the right. In what sections are you, what are you doing in that first section? So right where I put the roller coaster, you're going down, aren't you? So this is decreasing to here, and then this is increasing, and then this last section is decreasing. Is that good? It's increasing in the middle. You're going uphill in the middle, but on the left edge and the right edge, you're going down, aren't you? Does that make sense? Right, if I put the little roller coaster right here, going this way, you're increasing. I put the roller coaster over here, you're decreasing. Right, so you're increasing in the middle, decreasing on the outside. So what is the intervals there? Well, that means up to here, and then up to, I don't know what. It's kind of confusing. Oh yeah, what's all this pi stuff? That's weird, huh? Ah, they're trying to fool us. We're not going to be fooled, though. Well, you can see right here, this is pi over 2. And this is minus pi. So between minus pi over 2 and pi over 2, it's what? Increasing. Right there. Between minus pi over 2 and pi over 2, it's increasing. And it's decreasing from minus pi to minus pi over 2. And it's decreasing from pi over 2 to pi. Yeah, D. Those are all x values. By the way, I never cared about a y value. Intervals are always just the first number. And see how I just circled the first number in each parenthesis? Only x values for intervals. questions? We good? All right, on we go. 16. Find the average rate of change of this function. So same kind of thing. Average rate of change, what is it? It's slope, which is y2 minus y1 over x2 minus x1. So they say from x is -8 to +4. Let's find those points. Here's one of them. This is 1 point, x is -8. And +4, where's that? Oh, right here. This point, which is 4, 0. So those are the 2 points they're talking about. Everybody tracking with me? We're taking the point x is -8, so I found the one that has an x value of -8. And then the other one that has an x value of 4, I found that point. And so what they really want to know is they're saying, hey, what's the steepness between those 2 points? That's what we're really calculating, the slope, the average rate of change. Like, what's the steepness? How fast does the slope go down between those 2 points? That's what we're really figuring out. If you connected those two with a direct wire to skip over the roller coaster, what would be your slope there? On average, how fast would your height change? That's what we're asking. What's the slope there? So, all right. So it's so this is x1, y1. That's the first point's x and y value. This is x2, y2. Does that make sense? Just call the first point x1, y1, and the second one x2, y2. I'm just getting them off the graph according to the x values they gave me. All right. And then so it's y2 minus y1. So that's 0. Subtract y1, -5. Watch out for the double negative thing there. Right? There's subtraction in the formula. And then also, we're plugging in a negative number, so you know that's adding. x2, keep the order straight. x2 minus x1, again, double negative. That's going to become positive and positive, isn't it? You know all about that. Double negative, positive. Double negative, positive. Thank you. I'm messing up. That's right. I was just showing you how easy it is to mess up. I was just messing up. All right, so this should be a +5. Thank you. So I was going to get the wrong answer. All right, so this would be 0 minus regular 5. Thanks. Everything else right? Negative. Yeah, this should be -8 plus 5. Huh? And yeah, thank you. So the one at the bottom will become plus, but this one will stay minus. So the answer is -5/12. Oh, there it is. It's hard to see those little minus signs, huh? -5/12. There it is. We did these last time. Remember these ones? Where you're plugging into one graph and then into the other? Remember this kind of stuff? So they're asking us to figure out f of g of 3 here. F of g of 3. Okay, so remember how first we put 3 into g. So which graph is g? The graph on the left or the right? Over here, here's g. So remember, this is the x value, right? Whatever's in the parentheses is x. So 3, find the 3, go up to the graph, boom. What do you get? This is the point, over 3, up 5, isn't it? That's the x, and that's the y, or the g. Same thing, right? Y values are function values. So that's the y, or g, same thing. So g is 5, so out comes a 5, right? When we put 3 into the g function, out comes a 5, and now we put that, but that whole g is inside of f, isn't it? See how the whole g is inside of f? So what comes out of g, that 5, you plug into f now. So go over to f, plug in 5. There's the point. Over 5, up 2. So plug in that value. Out comes the f value, or y value, same thing, of 2. Answer's 2. See how I went through both functions? So practice that. You'll be good. All right. Number, we have room for 8. Yeah, here's 18 up here. So number 18. So they want us to find f of g of 2. f of g of 2. So we do that over here. So they want f of g of 2. What does that little circle in the middle mean?
Multiplication.
Not multiplication. Plug one into the other. Composition. Composing them together. So yeah, so it's not a dot. It's not a times dot. It's a circle on purpose, which means one of them's plugged into the other. In other words, it means this. F with g of 2 inside of it. That's what it means. That's what that little circle means. It means inside. One function into the other. So how do we do that then? Well, we start on the inside again, just like we did on that graph one. 2 goes into g. So I'm going to put 2 into g. So take the g function. Let's find the inside. What's the inside going to be? 3 times 2, right? That's the g function. It's 3 times whatever you plug into it. Everybody see that? Am I losing you? Maybe I can take that more slowly. So first off, g of 2. Here's the g of x function. G of x is 3x, right? So if you put 2 in, it's going to be 3 times 2, 6, isn't it? So that inside becomes 6. G of 2 becomes 6. Now, we've got to put 6 into the f function. Here's the f function. F of x is square root of x plus 3. So if we plug in 6, we get the square root of 6 plus 3, square root of 9, which is 3. There it is. Is that okay? Do you see what we do with those composition of functions? So you start on the inside, take the number, plug it into g, whatever comes out, plug that into f. So it's running through both functions, isn't it? Does that make sense? It's like putting your toaster in your refrigerator. That's weird, huh? Right? That's what composition of functions is like. Then you take a piece of bread and you put it in your toaster. You open the refrigerator door with the toaster sitting inside. You put the piece of bread in the toaster, push down the lever, close the refrigerator door. What'll happen? The toaster will make the bread into toast. It'll pop up. And then as soon as it pops up, the refrigerator will start cooling it down. And a few minutes later, you open the refrigerator, you got chilled toast. Something you never wanted. But the point is, both functions operate on it, right? That's what just happened with the G and the F, right? The G operated on the 2, out popped the toast, and then the refrigerator operated on the output, the 6. That's what's going on. All right, let's try 19. Same kind of thing on 19. Let's try that, see how that goes for us. So 19 says f of x is 4x squared plus 2x plus 6. And g of x equals 2x minus 7. And they want us to find g of f of x. Like that. So remember what that means. That means f is inside of g. So notice this one's the other order. The g's on the outside, the f's on the inside, and that order matters. So where do we always start? Inside, right? F of x. What's f of x? All of this. So this will be g of 4x squared plus 2x plus 6. You with me? That's f of x, isn't it? So f of x is inside of g. And so now we take all of that, all of this, and you plug it in right there. Because remember, the x in any function is the holes in the toaster. It's the insert slot. It's plug in right here. So I'm going to plug that whole thing in right there. And so what do I get? I get 2, and then the plug-in, 4x squared plus 2x plus 6. And then the, what is it? Was it minus 7? I can't even read it anymore. Yeah, minus 7. Let me put it back the way it was. Minus 7, yeah. And then we distribute, and we get 8x squared plus 4x plus 12 minus 7, 8x squared plus 4x plus 5. And there it is. Hopefully that's one of the answers. Oh, at 8 squared plus 4, yeah, it's D, isn't it? It's D.
C.
Oh, C. C, I'm looking at the wrong one. Yeah, they're close. It's C. Option C. There we go. Questions on that one? Go back to 20. Okay. Now that's an absolute value graph. And earlier, I said on your 3x5 card, there's all the graphs. Here's the normal absolute value graph. Notice how they're all originally centered at the origin, aren't they? So if they're not at the origin, they've been moved by adding and subtracting numbers. That's what we talked about in today's lecture, 3.5. So let's go find that. Getting back to this question. So here we go. So this will be a bunch of these. So again, remember, absolute value of x normally sits right here at the origin. But this one's been moved where? To the right, too. They took this, just focus on the center dot, that's always the easiest way. The whole graph, the center dot has been moved right to. So what's going to make A, B, C, or D, it's going to make it go right, going to make a graph go right to. Yeah, so which one is it, A, B, C, or D?
B.
It is B, right? It's got to be in the parentheses, the absolute value symbols, doesn't it? It's got to be in there with x, because it's an x effect. It's a right-left effect. See that? That's right. It's not D, huh? What would D do? That'd go down to, wouldn't it? Yeah, it's up-down. Stuff in there with x is right-left. Stuff outside's up-down. Let's try the next one. So now we're talking about square root. Again, that's why you want to have the big 6 on your card already. So you'll look and, like where I gave you back here. There it is. So there's the square root graph right here. That's the normal one that hasn't been moved. They always start at the origin. So you go, okay, there's the normal one right there. So y equals square root of x, starts at the origin, goes up to the right. Now, they've got a plus 1 here and a minus 5 there. What's that plus 1 going to do? What is it?
Negative? I'm going to go to the left.
Left, huh? Left one, because it's in there with x. It's in the root, so it's right, left, and it's opposite. X is always opposite. And then, what about the minus 5?
Down 5.
Down 5, that will. Yeah, so which one has been moved left 1, down 5?
B.
Yeah, this one, huh? See how this dot is left 1, down 5? That easy? All right, let's try another one. There's another absolute value. Again, they're normally at the origin. Figure out what the plus 5 is going to do and the minus 1. Plus 5 is left 5, yeah. And what's the minus 1?
Down 1.
Down 1. Which one's been moved left 5, down 1? D it is, right? Because this dot is left 5, down 1. That center dot right there. These ones are your favorites, right? All right. Now how about that one? Again, remember, it's always helpful that's why you want to go back here to the big 6 that you're going to have these 6 on your 3x5. Always start with the original. What does the original square root of x look like? Well, it starts at the center and kind of goes up. I always think of it like a firework. It looks like 4th of July to me, right? Because you set it on the ground and it shoots off to the right like that, right? All right. So we come on back. And so it's sitting right here. So here's the normal square root of x graph, like that. So what is this minus sign in the root going to do? Is that going to be a right-left kind of thing or an up-down kind of thing? Because it's in there with x. So it's going to make it go left, huh? So which one is it? There it is, going to the left now. Is that good? That's just like the homework we just did. See how I'm just giving you a few questions from this one's fresh because we just had it. That's what this exam is, huh? It's just a few questions from every one of our homework sections. That's it. I mean, I don't mean to make it seem simple, but it's a simple formula. Master all those sections and you will ace this exam. There are just a few questions, and mainly practice the practice exam. That's the main thing. All right, how about this one now? This one's got a couple of things going on. This one's a little more complex, huh? What is this minus 3 in the front going to do? Stretch it. And what about the negative part?
Makes it point downward.
Flip downwards. Yeah, it's going to stretch. Yeah, this 3 is going to stretch it and stretch it downward 3 times as fast, huh? So it's going to flip it down because it's negative. And because it's 3, it's going to flip and stretch. Flip and stretch it down. What's the plus 1 going to do? Yeah, it's going to slide it left 1. And finally, the minus 2? Down. Going to slide it down 2. So which graph? I'm going to start with the movement. They're all going down, huh? All the U-shapes are going down. So which one has been slid? Is that the word slidden? Which one's been moved? Left 1 and down 2. Yeah, this one, huh? You can tell this center dot right here is left 1, down 2, and it is stretched downward, isn't it? See that one? Is that good? All right. Now, at the end, I'm going to have, it might be 4, it might be 3. I can't remember exactly. It's probably 3. It might be 4. Questions that are not multiple choice, just like the last exam. There are a few that are not multiple choice that you just have to solve by hand and just leave your answer right on your test, and I'll just grade it. You can get partial credit on these. That's one thing that's nice. All right, let's start with number 25. I want to get through these for you, so I'll move kind of quick. Remember what you do with a real high power thing like that, x cubed? What do you do with that thing? Got to do what? Yeah, start factoring. Yeah. You look at these 3 and say, okay, what number goes into those? It's just 3. Yeah, you check them on your calculator. 3 goes into all those. And then what about the x stuff? Do they all have an x? Yeah. So what's the greatest common factor, the GCF I'm going to put in the front? 3x. And remember, you do the one big parenthesis first, and then on the next step you do the 2. Remember how that works? So 3x in the front first, and then you say, okay, 3x times what, and what? Going to be 3 things, huh? That would go back to the way it was before. So 3x times what first? X squared, because the invisible 1 power and the 2 will add. Remember, out front numbers multiply, powers add. Plus, what's next spot? 7x. The invisible 1 power is 3 times 7 is 21. The 1 powers add. Plus 12. 3 times 12 be 36, and it's got the x. Okay, now you do the 2 parentheses. The x is in the front, and they have to multiply. Remember how this works? Multiply to be 12, add to be 7. So what 2 numbers do that? 3 and 4. Both plus, huh? They'll add to be 7, multiply to be 12. But now we can't stop there. All these ones are equations. All of them. See the one, yeah, have you noticed my pattern? I always put the equations at the very end. Meaning the ones where you should get an x equals answer. So we don't stop here at the parentheses. I saw a lot of people on the last exam stopping at the parentheses here. Because you didn't have the multiple choice, and I think you didn't understand. So let me be super clear. No mysteries with me. These last 3 or 4 on the exam, you can't stop at the parentheses. You got to go on to get x alone in every one of these cases. So just know those ones at the end, got to get x alone. So what do we do next? What's our next step to get x alone? Yeah, each one is, remember how if a bunch of things are multiplying to equal 0, if you're timesing things to come out 0, any of them could be 0 to make them multiply out and be 0. Yeah, so you do them one at a time. You say, okay, the 3x can be 0, or the x plus 3 can be 0, or the x plus 4 can be 0. They can all be 0. Let me get a little more room there. Because their times can be 0. And then you just solve, right? Divide by 3. So that's just 0. Subtract 3. So that's negative 3. Subtract 4. And so that's negative 4. There it is. I don't care how you write it. You don't even have to have the x there. If you just show me 0, negative 3, negative 4, I'm very happy to give you full credit. Any kind of way. You can write 3 separate x's if you want, or just put them all in a big, just circle them all, whatever. But you can't stop at the parentheses. Does that make sense? We cannot stop. That's where you will lose the credit. You have to know that you go all the way to x whenever you're solving an equation, because there's an equal sign there. All right, how about 26? What do we do with absolute value? Let me bring that one over. 26, it's 4 absolute value, 8x plus 6 equals 28. So yeah, so what do we do with absolute value? Now we've had absolute value greater and less, still up there on the board, and you're going to have it on your 3x5 card. But what do you do with absolute value equal? Step 1, it's just about saying get the absolute value alone. So let's do that first. What do we got to do to get the absolute value alone? Divide, get that 4 out of there, because he's not part of the absolute value, is he? So we get rid of that, and that's what, 7? And then step 2. So step 1, get it alone. Step 2, you remove again. See how it's almost the same? Remove the absolute values. And when you remove, you say inside equal to the positive number, or inside equal to the negative number. See how it's just always positive and negative? So we say, okay, inside your positive 7 or inside your negative 7. No more absolute values, we removed them. And then you just solve both those for x, so subtract 6 from both. So 8x is 1. Oh, I forgot to do it on the other one, huh? Subtract 6. And last step to get x alone, divide by 8, divide by 8. There it is. The answers are 1/8 and minus 13/8. See how we always go on to get x alone on these last ones that are not multiple choice? There's our 2 answers. So you're going to want to put that on your 3x5 card. Let's try 27. 27 is a square root. 2 square root of 8x minus 5 minus 4 equals 8. So this is another game plan we need. So what's the game plan for solving a square root with an equal? Step 1, get the root alone. No big surprise there. That's what we pretty much always do. Step 2, remember, parentheses square, because that's the opposite of a root, a 2 power. And so first step, get the root alone. What are we going to do to get the root alone? Got to add that 4 to get rid of that. And we get 2 square root of x minus 5 is 12. Next step, to get the root alone, divide by that 2. Boom. And then the root is alone. So that's all step 1. Get the root alone. Step 2, parenthesis 2 power, parenthesis 2 power on both sides. And remember what happens there? 2 powers and roots are opposites of each other. Like a poison and an antidote, they neutralize each other. So these 2 cancel, and you just have 8x minus 5. The other side, 6 squared, is 36. See how it cancels on the left side, but it actually squares on the right side because the root canceled it on the left side? And now we just finish solving. Just add the 5. 8x is 41. Last step, divide by 8. There it is. Is that good? So this is LCD stuff, huh? What do we do with LCDs, common denominators? First off, you find the LCD, which is one of each type, right? In this case, it's going to be x and x plus 1. You don't need both single x's. You just need one of the single x's and the x plus 1. So one of each type. And you multiply LCD over 1 to every term. Remember that? So I'm going to go x plus 1 over 1 to the left, x plus 1 over 1 to the middle, x plus 1 over 1 to the right. Left, middle, right, LCD over 1. And then what do we do on step 3? Cross, cancel, and multiply the leftovers. So x will cancel x. What's left over? 32 with x plus 1 minus x plus 1 cancels x plus 1, 32x. X cancels x, 4x plus 1. You see what happened there? So I multiplied through by LCD over 1 to all three. And the LCD is one of each denominator piece. Cross cancel and multiply what's left over. So now I just distribute. Boom, boom. 32x plus 32. It's much nicer now because the fractions are gone. Distribute. 4x plus 1. 32x minus 32x. That's nice. That's golden. So finish it up. Yeah, just subtract the... 4. Thank you. I'm going too fast, aren't I? Thank you. So don't go too fast. I was just trying to show the dangers of going too fast. I have a lot of lines. I could be a used car salesman. All right. Subtract the 4. Thank you. 28 is 4x. Last step. Divide by 4. And x is 7.